So, that being said, we're going to take a look at some doing limit calculations with equations. And there are some different techniques we're going to talk about with this. The first thing you always try and look for when you're trying to do a limit with an equation is, can I just plug it in? You always hope for those. Those are called substitution limits. Okay, so that's kind of like, because you're going to kind of go through this progression. Check for this, check for that, check for that, check for that. So substitution is the first thing you want to check for. Can I just plug the number in? So example of a substitution limit. So if we had like the limit as x approaches 2 of x plus 5 over x minus 3. Okay. So put in a 2 and see what happens. Okay. So 2 plus 5 over 2 minus 3. So that's 7 over negative 1, so negative 7. The answer to that limit is negative 7. Done. So check to see, can it be plugged in? Now, if it can't be plugged in, then you might have to go to doing something else to get there. Okay, we have some limit properties we're going to talk about. But before that, you might have to try to simplify what you have. And when we did all of that rate of change business with limits, this is what we were doing. This is the stage we were at, was trying to simplify. So, to give you an example, so let's say we get the limit as x approaches, how about 4 this time? All right, so if I try to go with this one, doing a substitution, immediately you can see the problem with that, right? What's going to happen if I try to do this one like a substitution limit? You're dividing by 0 again, which is bad. So what we're hoping for then is, can we factor some things out, do some cancellations, so that this x minus 4 just goes away? And then we can take whatever's left over and plug in and use that then. Okay? So x squared minus 6x plus 8. You guys factor that for me here. What are our two factors for that? There you go. Yeah. So x minus 2 and x minus 4. And then the x minus 4s will cancel. Yep. And so we'll be left with the limit as x approaches 4 of x minus 2. So what we've done is we've done some simplifying to turn it into a substitution limit, because now I can plug in, it's not a problem. 4 minus 2, that's 2. So the answer to that limit should be 2. So substitution, try to simplify. Those are kind of your first two things that you're going to check. If those two things don't work out, you might need to use a limit property. So I'm not going to write all of these down, but we're going to kind of skim through them in your book a little bit so you can at least take a look at them. And then I'll show you how you can use a limit property to get at a limit. Okay, so number 3, use a limit property of some sort. So here's what we got for that. This is on page 61 if you're interested in your textbook. But these are some of the properties that we have. So, and all of this are things that we've looked at in different contexts, not with limits, but each of these I think should make a little bit of sense to you. Okay? So, at the beginning it says, the limit as x approaches some number c of f of x, let's assume that that's equal to some number we know and it's L. And the limit as x approaches c of some other function g of x, let's assume we can calculate that and that comes out to m. So the rules go like this then. If you want to do the limit as x goes to c of these two functions added together, then the answer is going to be their two answers added together. Does that make sense? And if you subtract, you subtract. Okay, take their answers and subtract them. If you multiply them. If you take one limit and multiply the function in the limit by a constant, then it's the answer to that limit, whatever it was, L in this case, multiplied by that constant. Okay? So like if I know the answer to the limit of x squared at some value, I can do 2x squared just as easily. I can just take the answer to the first one and multiply it by 2. Whatever that number is you're multiplying, and the outside of that, you can just multiply that to the answer, and then you can get your answer that way. Quotient rule, if you divide the two functions, you can divide the two answers, assuming that this one doesn't come out to 0, that m is not equal to 0, because then you've got that same issue of dividing by 0, and then it's a limit you wouldn't be able to do anyway. Okay? So that's why they put this little m not equal to 0 part at the end. Okay? So we've got all of those properties. Let's see. And then there's a power rule. This is at the top of the next page here. And the power rule says, if r and s are integers, so if it's raised to some power, and s is not equal to 0, because then you'd be dividing by 0 in this little fraction up here, it is the answer to the limit raised to that same power. So basically with all of these, it's saying if you're doing some kind of an operation inside of a limit, you can just take the answers to those limits and do that same operation to them, and the answer should still be the same. Okay? So, using some of these properties then, see how we can get that to work for us. So what I'm going to do, to really show you a good utility with this, I'm going to show you a limit that at this point you're not going to be able to calculate, but we're going to use it for our purposes here. So, and this is a limit, whoops, I put x in there. This is a limit that you will have memorized at some point, because we're actually going to use it quite a bit. But, and I'll show you why this is in a little bit, but the limit as x approaches 0 of sine x over x, do you see why you can't do a substitution for that one? Because it would give you divide by 0 again, right? And do you see how we can't simplify that one? There's no way to factor sine x. We can't cancel anything. We're kind of stuck, right? Okay. The limit does have an answer. And like I said, later on I can show you how we can get that, but it's equal to 1. The limit as x goes to 0 of sine x divided by x is equal to 1. Okay. So knowing that fact, let's see if we can calculate the limit as x goes to 0 of 2x plus 3 sine x over x. So I'm going to use some of those limit properties by taking this limit and breaking it into several limits. and then taking each one of those limits one at a time and calculating them, and then getting an answer from that. Okay? So it's really going to just involve a little bit of algebra to get it set up the way that we'll be able to do it. Okay? So the first thing I'm going to do is I'm going to distribute this x so that I've got that to begin with. Okay? So I'm doing the limit of all of that now. 2x over x plus 3 sine x over x. And that first fraction, we can cancel out the x's then, right? We can do a little simplification job on that one. So we end up with the limit as x goes to 0 of 2. And then I'm going to use one of my limit properties and say, okay, if I'm doing the limit of two things added together, that sum rule said that I can break that into two limits. Do the limit of the first one and the limit of the second one. So I'm going to make this another limit as x approaches 0 of 3 sine x over x. Okay, so I've used that sum property to break that up. And then I'm going to use one more property. There's that constant multiple rule that said if I've got something that's multiplied by a constant, in this case, this sine x over x technically is getting multiplied by 3, right? So I can take that constant multiple and put it out in front of the limit then. I can get the value of the limit and then multiply by 3, and it's the same thing. So my whole equation here now is going to look like this. And now I have the means to actually calculate that. What is the limit as x approaches 0 of 2? If it's helpful, think about what that function looks like. It's just a straight line at 2, right? So it should be 2. It's always 2. There's no x to plug into. It's just 2. Okay? And then I have 3 times the limit as x goes to 0 of sine x over x. What is this? That's equal to 1, right? So 3 times 1. 3. And then 2 plus 3. The answer to this limit is 5. Okay, so that's how we can use some of those properties to help us out. If you have a known limit, like this sine x over x one that I told you, then we can use some of those properties to take one that looks on the outset like it's impossible. Like, I can't simplify that. There's a sign in the mix there. I can't cancel anything. I don't know how to do this. But if I start to break it apart using my properties, then I've got two very doable limits, knowing this fact up here that we started with. And then I can use that to get my way through the whole thing. Okay, so